G'day students, Mr. Cockrell here. Good to see you. I hope everyone has had a great week and are ready to get into today's content. So today we will be talking about bonding. Bonding is pretty much where we're putting together and combining what we've learned over the past few lessons into actually how it applies in the real world. So let's start with ionic bonding. So ionic bonding is just the strongest type of bonding. It is between two ions, and it's a give and take of electrons. So what was an ion? Can someone remind me? Yes, exactly. So an ion is when an atom loses or gains an electron. So it's between two things, two charged atoms. So for example here we have lithium plus, which indicates that it has lost an electron, and F minus, fluorine minus, because the fluorine has gained one more negative charge, which makes it minus. So if we look on our periodic table is amazing because it can show us what our atoms want to do. Lithium is in our first column here, and so it shows that it wants to give one electron away so that it has a full outer shell, full valence shell. Fluorine, on the other hand, is in our group 17 or our group 7, and it wants to take one electron. It wants to receive one so that it has a full outer shell once again. So if we're looking at a few diagrams here, we have lithium on the left here, which has 2 electrons on the first shell, and then 1 on the second shell. And our periodic table shows us this. So it shows that we have 3 protons, therefore 3 electrons. So then we start to fill our shells out from inside out. So our first shell holds 2, second shell holds 8, and our third shell also holds 8. So fluorine over here, so this is what an electron configuration diagram would look like for it. So we have 2 electrons in the middle, and then 7 around the outside. Now, I've drawn a little circle here because this shows that fluorine is missing one. It really wants to gain that 1. To have a full outer shell, it could either lose the rest of the 7 or just gain the 1. So it's much easier and takes much less energy to just gain that 1. So lithium comes along, fluorine comes along, and bam. Lithium will give that electron over to fluorine. So it's essentially sitting that electron over fluorine, and suddenly both atoms are stable. Whilst they're charged, which means one side's positive, one side's negative, they are stable, they're happy. So this shows that it's bonded ionically. And so, just quickly, this is called electrostatic attraction, where we have a positive and a negative, and they're attracted to each other. It's like a magnet. So you put the positive and positive ends together, then they'll push away from each other, but positive and negative, and they're drawn closer. So if we look at our next type of bonding here, we're looking at covalent. This is between non-metals. So if we're looking on our periodic table, up in the top right-hand corner, this is where neither atom really wants to give or take an electron more than the other. It's a sharing of electrons. Now we're going to explain this in a little more depth here. So for example, if we have O to O, so oxygen bonded to another oxygen, this makes O2, the air that we breathe, or oxygen that we breathe. Oxygen has 8 protons according to the periodic table, so therefore 8 electrons. So if we draw our electron diagram, we have 2 in our first shell, fill them up, and remember we're trying to repel each other, those electrons. And then the second shell, we still have another 6 electrons. So we put 1 in each position, one of the 4 positions, and then start to pair them up. So we're left with 2 unbonded electrons there, so 2 lone pair electrons. So those 2, oxygen on the left there really wants to gain 2 more electrons, but there's also oxygen on the right. Now neither of them really have anything around which would gladly give up 2 electrons, so to make each other stable, they bond together. And so this is where that sharing of electrons come together. So as you can see, both atoms really want to gain 2 electrons, and both atoms have 2 electrons sitting there. It's just that they don't really want to give them away. So these kind of sit in the middle and bond. This is how sharing comes about from it. So these are bonded covalently. And our last type of bonding is, I think, the most fantastic. I love it because our modern world's based around this. So it's between metals. It's the flow of electrons that makes metals malleable. So malleable just means bendy, able to be squished or reshaped. And so we just have a whole bunch of magnesium atoms here. And rather than drawing an electron configuration diagram, because metals have such a loose hold of their electrons, and so many of them, remember we said that the further the magnets away from each other, so the further the nucleus is from the electrons, the less strength it has. These electrons are delocalized, we call them. So they're just floating around in the middle. They're happy to go anywhere. And this is what allows metals to be malleable and bend. So I said electrons here are delocalized, which means they're not attached to an atom. Rather, they flow between them. And this is really cool. So just a quick example of each type of bond. Ionic bonds, they're our strongest type of bonds between generally a metal forming a salt, metal and non-metal forming a salt. And so table salt, for instance, is sodium chloride, NaCl. Covalent bonded, so this is always between our non-metals. Often our gases are covalently bonded, where they just want to share electrons. Now metallic bonding, this is where our electrons are delocalized, and this allows our metals to bend, etc. So thank you so much for listening, and excited to see you in class. Bye.
I just blew my mind.